Usually when we talk about a military defense system, there is this underlying expectation of mass.
Yeah, absolutely.
If you look at the entire history of human conflict, from like a medieval castle to a modern Aegis destroyer, it all essentially boils down to mass impacting mass.
It really does. It is fundamentally a kinetic paradigm, which has dictated military strategy for, well, thousands of years.
Right. You build a massive concrete bunker, you forge thick steel plating, and when someone attacks you, you launch a heavy kinetic interceptor missile.
Exactly. We calculate intercept trajectories based on the sheer physical momentum required to shatter an incoming threat.
You are basically just throwing a very fast, very expensive rock at another very fast rock, hoping they collide in midair.
And we find comfort in that solidity. We like our defensive walls to be visible, to have actual weight, to be categorized as impenetrable physical objects.
It's solid. I mean, it's easy to wrap your head around. If I want to stop a bullet, I just put a thicker piece of metal in front of it.
But when you examine the current trajectory of things like hypersonic glide vehicles and saturation drone swarms, that entire kinetic philosophy really begins to buckle.
Which brings us to the highly classified sounding stack of engineering blueprints and technical roadmaps we are unpacking today.
Yes.
We are looking at a defensive landscape that abandons the physical rock entirely. It steps so deeply into the world of advanced directed energy physics, nanomaterials, and magnetohydrodynamics that it sounds honestly like absolute science fiction.
I mean, it is the absolute definition of a paradigm shift.
Yeah.
We're moving from kinetic mass to pure structured energy.
For everyone listening, we're talking about stopping a Mach 10 missile, not with a concrete wall or a titanium interceptor, but with what is functionally an electromagnetic smoke ring.
Right. And what is truly fascinating about the GVP platform outlined in these documents is that while the end result sounds like something straight out of a space opera, the foundational building blocks are entirely real.
That's the part that really hooked me. We are tracking the evolution of this technology from its origins as a theoretical, portable, non-kinetic plasma rifle all the way into its final, truly terrifying form.
The strategic point defense configuration?
Yes, known in the engineering roadmaps as the Iron Vortex, or sometimes the GVP-6 Apocalypse and GVP-7 Omega.
Very dramatic names, but they fit the capability.
A nuclear-powered, anti-hypersonic missile shield, but, and I want to stress this to you listening, it is not magic. It is grounded in cutting-edge material science, specifically MXene-graphene composites, and verifiable plasma confinement physics.
The challenge with analyzing these speculative platforms is usually parsing the real physics from the theoretical leaps. But the math in these blueprints actually holds up. They detail a masterclass in solving engineering bottlenecks.
Let's start with the most basic component then, because before we can understand how this iron vortex creates an impenetrable area denial shield against a swarm of hypersonic missiles, we have to look at the ammunition.
Right. What is it actually firing?
Exactly. It's not a bullet and it's not a continuous laser beam. The documents call it a plasma-acoustic toroidal vortex.
So if we strip away the technical jargon for a second, a toroid is just a donut shape.
Okay, a donut.
And a vortex ring is a spinning structure of fluid or gas. If you picture a smoke ring blown from a cigar, or those beautiful, perfectly circular bubble rings that dolphins create underwater, you are visualizing a toroidal vortex.
So the fluid is spinning in a continuous loop, kind of rolling forward on itself.
Exactly. And from a fluid dynamics perspective, looking back to the vortex theorems developed by Hermann von Helmholtz in the 19th century, this structure is incredibly stable.
It holds its shape.
It self-organizes. Because the fluid is rotating around a circular axis, it carries energy and momentum over a distance much more efficiently than a standard broadcast wave, or just, blowing a dispersed puff of gas into the air.
But a dolphin's bubble ring or a puff of cigar smoke doesn't have the energy to stop a missile.
Far from it. The GVP platform generates a plasma toroid. It is an electromagnetic smoke ring. And creating it requires a massive, instantaneous injection of energy.
How massive are we talking?
Well, the process begins inside the weapon's confinement chamber with a femtosecond laser.
A femtosecond being 1/quadrillionth of a second.
Right. To understand how unimaginably brief that is, a femtosecond is to 1 second, what 1 second is to about 32 million years.
Oof, really?
Yes. The system fires a gigawatt-class laser pulse into the ambient air inside the chamber for just a few of these femtoseconds.
Why such a short pulse, though? Like, why not just use a continuous high-power laser?
Because of how energy density works. If you deliver a moderate amount of energy over a long period, you just heat things up.
Okay.
But if you deliver that same amount of energy in a quadrillionth of a second, the peak power spikes to astronomical levels. This ultra-short, ultra-intense pulse triggers a quantum mechanical process called multiphoton ionization.
Okay, let's break that down. Multiphoton ionization.
Normally, a single photon of light from a laser might not have enough energy to knock an electron free from a nitrogen or oxygen molecule in the air.
Right, the air is pretty stable.
But because this femtosecond pulse is so incredibly dense with photons, the air molecules are struck by multiple photons simultaneously.
Oh,
This basically shatters their structural integrity, ripping the electrons violently away from the atomic nuclei.
so it literally turns the ambient air inside the barrel into plasma.
Exactly. It creates an avalanche breakdown. One ionized electron smashes into another atom, freeing more electrons, cascading in a billionth of a second until you have a dense plasma kernel.
A spark.
A very intense one. The documents specify an electron density of up to 10 to the 20th power per cubic centimeter. That is an incredibly thick, charged soup of plasma.
So we have this highly charged, glowing seed of plasma sitting in the chamber.
From there, the weapon uses complex microwave pulses, specifically tuned in the 1 to 10 gigahertz range, along with specialized magnetic arrays to manipulate that plasma.
Because plasma is electrically charged, so it responds to magnetic fields.
Right. The system spins this plasma kernel into that donut chase, the toroid, and accelerates it out of the barrel at extreme velocities.
And when you say extreme velocities, I mean, the specifications note these rings are traveling anywhere from Mach 5 up to Mach 20 or higher.
Yeah, hypersonic speeds.
You have a glowing, spinning ring of plasma flying at 20 times the speed of sound. And the sheer energy contained in this structure is staggering.
It really is.
The documents specify the bursts are operating on the megajoule scale, 1 to 10 megajoules per toroid for the tactical units, and pushing up to 50 megajoules for the Omega configuration.
To put that in perspective, if you picture a 1-ton vehicle, like a compact car, moving at 100 miles per hour and hitting a solid wall, the kinetic energy transferred in that crash is roughly 1 megajoule.
Wow. But in the GVP, we aren't just talking about the physical impact of a car crash.
No, this is tightly concentrated thermal and electromagnetic energy. The thermal energy alone in a 1 megajoule burst is sufficient to instantaneously melt approximately 1 kilogram of aerospace-grade aluminum.
Instantaneously. Not melting it over a few minutes in a furnace, instantly turning solid titanium or aluminum into liquid.
The core temperature of this plasma vortex can reach between 10,000 and 1 million Kelvin. We are talking about conditions approaching the outer layers of stellar cores.
Okay, hold on. This is where my brain starts to hit a wall and where I have to ask the obvious practical question.
Go for it.
I understand the concept of using a femtosecond laser to make a 1,000,000-degree smoke ring, but you are telling me we are generating a 10 megajoule plasma seed, reaching temperatures of 1,000,000 Kelvin inside the physical metal and plastic chamber of a weapon.
Yes.
How does this thing not just instantly turn into a puddle of molten slag the moment you pull the trigger? I mean, it's like trying to hold a piece of the sun inside a thermos.
That is a great analogy. And you've just identified the exact engineering bottleneck that historically prevented directed energy weapons of this magnitude from moving past the theoretical stage.
It's just too hot.
In the realm of high-energy physics, they refer to this as the risk of dielectric breakdown.
The weapon basically zaps itself.
The intense heat, combined with the extreme magnetic fields required to contain that plasma, creates unimaginable thermal stress.
Right.
Historically, if you generated this much energy in a confined space, the heat buildup would destroy the internal architecture, warp the barrel, and fry the electronics before a second shot could even be loaded. The system suffers fatal thermal fatigue.
So how does the iron vortex solve the thermos problem?
This is where the speculative physics gives way to some of the most cutting-edge, real-world material science we have today. The solution is the integration of a multi-layer MXene-graphene aerogel core.
Let's unpack these materials because this seems to be the linchpin of the whole system. I know graphene, right? It's the single layer of carbon atoms arranged in a hexagonal lattice.
Yes, exactly.
It's incredibly strong, highly conductive, and it won a Nobel Prize a couple decades ago. But what is MXene?
MXenes are a relatively new, highly versatile class of two-dimensional inorganic compounds. They were first discovered around 2011.
Okay.
They consist of transition metal carbides, nitrides or carbonitrides.
So similar to graphene, they are effectively 2D, like only a few atoms thick?
Yes, they're synthesized by selectively etching away specific atomic layers from a bulk crystal, leaving behind these ultra-thin sheets.
And then they combine them.
Right. When you take MXenes, you combine them with graphene, you get a hybrid nanocomposite that inherits the best properties of both.
Which gives you what exactly?
You get exceptional electrical conductivity, an incredible strength-to-weight ratio, and most importantly for the GVP platform, unprecedented thermal management capabilities.
And the blueprints specify they construct an aerogel out of this hybrid material.
Yes, an aerogel.
An aerogel is essentially a solid cloud. It's a structure where all the liquid has been replaced by gas, making it mostly empty space, incredibly light, but structurally rigid.
Creating an aerogel from these 2D materials involves stacking them into a porous, three-dimensional scaffold. The confinement chamber and the energy storage buffers of the iron Vortex are lined with this MXene-graphene aerogel hybrid.
Okay.
And this structure possesses a property known as tensor thermal conductivity.
Tensor thermal conductivity. Contrast that with normal thermal conductivity for me.
If you take a standard block of metal, say copper or steel, and you apply heat to one point, that heat flows relatively evenly in all directions outward from the source.
Like a growing sphere of warmth.
Exactly. It is a scalar property.
Right. If I shoot the bottom of a cast iron pan, the heat spreads out in a circle and eventually moves up the handle.
But in these engineered 2D nanomaterials, the atomic lattice dictates how the heat moves.
Yeah.
Heat is carried by phonons, which are basically quantized waves of acoustic vibration traveling through the atomic lattice. In the MXene-graphene aerogel, these phonons travel incredibly fast along the flat planes of the 2D sheets, but they travel very slowly across the gaps between the layers.
Oh, so it's not a sphere of heat, it's directional.
It acts like a highly engineered thermal superhighway. The heat from that 1 million Kelvin plasma seed doesn't just radiate out randomly and melt the weapon's vital sensors.
That makes sense.
Instead, the aerogel captures the heat and instantly channels it away along specific predetermined pathways, distributing it safely through the broader chassis, or heat sinks.
Oh, wow. It's practically routing the heat like a circuit board routes electricity.
Furthermore, the aerogel acts as a phase change material, or PCM.
What does that mean in this context?
It means it can absorb a massive amount of thermal energy by slightly altering its internal structure at the microscopic level without physically melting or breaking down.
So it drinks the heat of the sun, routes it away from the sensitive electronics, and stores it in its own structure.
This rapid absorption and directional dissipation enables what the engineering roadmaps call instantaneous chamber recovery.
Chamber recovery.
Yes. The aerogel manages the extreme thermal load so perfectly that the chamber cools down in fractions of a second. It completely circumvents dielectric breakdown.
That's incredible.
The residual thermal waste is cleared, allowing the system to achieve a rapid firing cycle, launching multiple megajoule bursts per minute without the internal structures warping or failing.
So we have a weapon that survives its own apocalyptic heat. That is a massive engineering leap.
A vital one.
But this introduces the next major bottleneck in the roadmap, because we have solved the thermal issue for a tactical single-shot weapon, right?
Right.
Firing a single megajoule burst from a portable backpack-sized battery is an amazing feat for infantry. But the goal of the iron vortex configuration is strategic theater-level defense.
Yes, a much larger scale.
It is designed to stop a coordinated, sustained swarm of hypersonic missiles. You can't do that with a backpack battery.
No, you absolutely cannot. And this leads us to the fundamental limitation of portable power technology. Traditional chemical batteries, like the lithium-ion cells in our phones or electric cars, lag significantly when it comes to instantaneous high-power delivery.
Because they rely on a chemical reaction to release electrons.
Exactly. Chemical kinetics take time. Batteries can store a massive total volume of energy, but they release that energy slowly.
You can't rush the chemistry?
If you try to pull a gigawatt of power out of a standard chemical battery in a single millisecond, the internal resistance will cause it to overheat and likely explode.
Yikes. So what's the alternative?
Supercapacitors. They store energy electrostatically rather than chemically.
Meaning they just hold the electric charge physically on their surfaces, ready to go.
Right. Because there is no chemical reaction required, a supercapacitor can dump its entire energy payload almost instantly. This is exactly what you need to create the megawatt and gigawatt scale pulses required to form the plasma toroid.
So a battery is a marathon runner, but a capacitor is a sprinter.
That's a very good way to look at it. The problem is that portable supercapacitors lack the total energy volume or energy density required for sustained defense.
Because they're sprinters.
Exactly. A portable GVP system might hold enough charge for a few semi-automatic megajoule bursts, but then it requires significant downtime to recharge.
Which is fine for a single skirmish, maybe.
But in a strategic point defense scenario, defending a military base or an aircraft carrier against a swarm of incoming Mach 10 missiles, you cannot afford 30 seconds of downtime. You need an effectively limitless supply of instantaneous power.
Which is where the blueprints introduce the nuclear pump.
Yes, the nuclear option.
The documents state that the stationary theoretical max version of the iron vortex utilizes a nuclear-derived power source. But the mechanics here are very specific. Let me try an analogy.
Okay.
It is like trying to fill one of those massive 1,000-gallon dump buckets at a water park, but you only have a standard garden hose. The garden hose is the nuclear reactor. It provides a constant, never-ending flow of water, but the bucket is what stores it up, tilts over, and drops the massive catastrophic wave all at once.
The water park bucket is actually a highly accurate representation of the electrical engineering at play here. In the baseline model for the iron vortex, the system integrates a small modular reactor, or SMR.
Providing a 1 megawatt continuous electrical output.
Yes. The nuclear source acts as a constant current pump, feeding a steady stream of power into the system. But it is vital to understand that the nuclear reactor is not powering the weapon directly.
And reading this, my first thought was, well, why not? If I have a nuclear reactor hooked up to a plasma cannon, why can't the reactor just power the blast itself? Why do we need the bucket?
Because of the instantaneous mechanical and electrical stresses involved. A nuclear fission reactor, even an advanced modular one, is designed for steady, sustained, stable output. Firing a 10 megajoule plasma vortex in a single millisecond requires a peak power pulse of roughly 1 gigawatt.
1,000 times more power than the reactor is outputting.
Exactly. If you attempted to pull 1 gigawatt of instantaneous power directly from a 1 megawatt reactor, you would cause a catastrophic grid collapse.
The bucket would break the hose.
The violent surge in electrical demand would physically destroy the generator's power transfer systems, melt the wiring, and potentially trigger a shutdown of the reactor core itself. The reactor provides sustained megawatts, but the weapon demands instantaneous gigawatts.
So you need a massive buffer.
A huge one. The buffer is an incredibly scaled-up version of the MXene-graphene supercapacitors we discussed earlier.
Oh, they use that same material.
Yes. The nuclear generator is solely responsible for trickle charging a massive supercapacitor bank. The documents model this buffer as a 100-liter volume bank, which is roughly the size of a large commercial water heater.
A water heater full of supercapacitors.
And because these advanced 2D nanomaterials possess a volumetric capacitance of over 500 farads per cubic centimeter, and the roadmap actually projects scaling this up to 50,000 farads per cubic centimeter, this 100-liter bank can hold an absolutely staggering amount of energy.
How much?
Between 3 to 30 gigajoules of stored energy.
30 gigajoules. Sitting in a tank the size of a water heater.
The supercapacitors act as the ultimate accumulator. They bridge the gap between the generator's constant steady output and the weapon's violent need for near instantaneous bursts.
Right.
The nuclear reactor continuously fills the buffer, and it is the buffer that actually dumps the 1 gigawatt peak power pulse into the confinement chamber to spark the iron vortex.
This total separation of power sources completely protects the nuclear reactor from the shock of the firing cycle.
Exactly.
The reactor just hums along, completely oblivious to the fact that the weapon is firing 10 megajoule blasts. And because the reactor is constantly trickling power in, the supercapacitor bank is refilling almost as fast as it empties.
It allows for a sustained high-energy rate of fire. The system can support a continuous fire rate of up to 60 strategic-level bursts per minute, indefinitely, as long as the nuclear core has fuel.
Wow.
It completely bypasses the recharge limitations of a battery-operated system.
So we have solved the heat problem with the tensor thermal conductivity of the aerogel. We have solved the power supply problem with the nuclear supercapacitor hybrid.
Right.
The weapon is sitting there humming with limitless nuclear energy, perfectly cooled, ready to fire 60 times a minute. But, that entire setup is completely useless if you're firing blindly into the sky.
That is very true.
And this leads us to the next massive technological leap in these documents. The target isn't a slow-moving drone. It is a stealth hypersonic missile. How do you hit something moving at Mach 10 that doesn't show up on radar?
This brings us to the stealth problem, which is arguably the most critical vulnerability in modern air defense.
Right.
To understand this solution, we have to look at how traditional electromagnetic radar functions.
Radar is basically just shining an invisible flashlight into the sky and looking for a reflection.
Essentially, yes. A radar installation broadcasts radio waves. When those waves hit a physical object, they bounce back to a receiver.
Makes sense.
By measuring the time it takes for the echo to return and the Doppler shift of the wave, you determine the object's distance, speed, and trajectory.
So how does stealth beat that?
Stealth technology, whether on a B-2 bomber or a modern hypersonic glide vehicle, evades this through two primary methods.
Geometry and material.
Exactly. First, the geometry of the craft is mathematically calculated to scatter incoming radio waves away from the receiver. Instead of bouncing the signal straight back to the radar dish, it deflects it out into empty space.
Okay, so the flashlight beam bounces off into the woods instead of back at your eyes?
Right. Second, the surface is coated in radar-absorbent materials, or RAM. These are compounds containing iron particles or carbon nanotubes that absorb electromagnetic energy and convert it into minute amounts of heat.
If the radio waves don't bounce back, the radar screen remains blank. The target is effectively invisible.
It minimizes the radar cross-section to the point where a multi-ton aircraft appears as small as a bumblebee on a screen, or just vanishes entirely. Traditional electromagnetic sensors are rendered useless.
But the iron vortex system doesn't rely on traditional radar, does it?
No, it abandons the bounce-back electromagnetic model entirely. Instead, it integrates something called a quantum lattice detector, or QLD.
The quantum lattice detector, the terminology in these documents is just fantastic. How does a QLD reveal a target that is perfectly designed to absorb and deflect radar?
It operates on a completely different physical principle. The foundational logic of the QLD is that stealth is ultimately an optical and electromagnetic illusion.
An illusion.
An invisible missile, perfectly shaped to deflect radio waves, is still a physical object with mass and volume. And as it travels through the atmosphere at Mach 10, it must physically displace the air molecules in its path.
Right, you can't move through the air without pushing the air out of the way. It takes up physical space.
The quantum lattice detector utilizes advanced quantum scale sensors, likely based on Rydberg atom interferometry or similar hypersensitive quantum states, to continuously map the local atmosphere.
How does it map it?
It treats the air surrounding the defended area as a predictable three-dimensional lattice of molecules. The QLD constantly monitors this lattice, identifying precise moisture concentrations, minute density gradients, and molecular turbulence at an atomic level.
It is essentially creating a real-time, high-resolution, 3D topographical map of every gust of wind, every pocket of humidity, and every pressure change for kilometers around the base.
Yes. And when the stealth missile traverses this atmospheric lattice, it violently disrupts it. The missile leaves what the documents refer to as a quantum wake.
A quantum wake.
It is a phantom trail. The sudden massive displacement of air, combined with the intense thermal friction of hypersonic travel, causes minute gravitational anomalies and electromagnetic disturbances in the atomic structure of the air left behind.
So it's not looking for the missile.
The QLD doesn't see the missile itself. The radar-absorbent paint is doing its job. What the QLD sees is the hyper-precise, highly pressurized tunnel of displaced air that the missile just carved through the sky.
Incredible.
By detecting this quantum wake, the QLD immediately illuminates the exact position, trajectory, and velocity of the low observable threat.
I picture it like looking at a completely invisible speedboat racing across a lake. You can't see the boat itself because it has perfect optical camouflage.
Right.
But you can perfectly track the massive ripples and the violent V-shaped wake it leaves in the water. The wake tells you exactly where the boat is and how fast it's going.
That captures the mechanism perfectly.
But wait, I have to push back here. A calm lake is one thing. But the atmosphere isn't a calm lake. It is incredibly chaotic.
It is.
You have wind shears, thunderstorms, heavy rain, and just natural, everyday turbulence. If the QLD is so sensitive that it's measuring minute density gradients, how does it tell the difference between the wake of a stealth missile and just a really strong, sudden gust of wind?
The AI filtering system is what makes the distinction possible. A gust of wind is a bulk movement of air, right?
Right.
It has a specific, chaotic, fluid dynamic signature that follows natural meteorological patterns.
Right.
A thunderstorm produces broad, erratic density gradients over a large area.
Messy.
But a stealth missile, moving at Mach 10, creates a highly ordered, mathematically predictable disruption. It generates a needle-sharp, ultra-high pressure shock front, immediately followed by a hyper-low pressure vacuum trail.
Ah, okay.
This follows the precise physics of the Navier-Stokes equations for supersonic fluid dynamics. The QLD's ultra-high-resolution capabilities allow it to filter out the ambient noise of natural weather.
Because weather doesn't look like that.
Exactly. It recognizes that natural wind doesn't create a perfect geometric vacuum cone traveling at 7,000 miles per hour.
Yeah.
It easily isolates the artificial high-velocity disturbance from the natural atmospheric lattice.
So the QLD strips away the camouflage. The invisible target is illuminated by the very air it pushes out of the way. We know exactly what it is. But knowing where a hypersonic missile is and actually hitting it are two very different problems. The QLD has found the target. Now, the weapon has to physically reach out and deliver this 10 megajoule smoke ring to a target moving miles per second through a chaotic atmosphere.
This is where human operators are completely removed from the loop.
I would assume so.
Human reaction time, even at the physiological limit of a few hundred milliseconds, is vastly insufficient for hypersonic interception. By the time a human operator processes the radar blip and pulls a trigger, a Mach 10 missile has traveled roughly 2 miles.
Wow. 2 miles in the blink of an eye.
The AI targeting system takes over completely.
It receives the real-time lattice map and the quantum wake data directly from the QLD.
Yes. And crucially, it doesn't aim at the target's current position.
Right, you have to lead the target like a quarterback throwing to a receiver.
Exactly. The AI calculates the optimal intercept trajectory by running predictive physical models. It uses the high-resolution feedback of the target's current velocity, mass, and heading to predict exactly where the stealth threat will be seconds in the future.
Okay.
It calculates the exact vector required to ensure that the megajoule-scale plasma toroid intersects the target's flight path perfectly in three-dimensional space.
But calculating the math on where the toroid should go is only half the battle, isn't it? The other half is ensuring a spinning ring of 1 million Kelvin plasma actually survives the journey through the atmosphere.
That is the hard part.
Because, as we just discussed, the atmosphere has wind and humidity. If I try to blow a cigar smoke ring through a hurricane, it dissipates instantly.
That is a major challenge for directed energy in the atmosphere. Vortex stability naturally decays with distance, even in a vacuum. That decay is exponentially accelerated by atmospheric interference. For instance, water vapor in the air is highly effective at absorbing electromagnetic energy. Crosswinds disrupt the physical symmetry of the toroid, causing it to wobble and break apart.
So how do they fix that?
To counter this, the iron vortex integrates a system called the SAPIN.
SAPNN, the Self-Adaptive Physics-Informed Neural Network. Let's unpack how a neural network keeps a plasma ring intact. What does it mean for a neural network to be physics-informed?
A standard neural network learns purely from massive amounts of data, finding patterns without understanding the underlying rules of reality. It just matches inputs to outputs.
Okay.
A physics-informed neural network has the actual laws of physics, like Maxwell's equations for electromagnetism and the Navier-Stokes equations for fluid dynamics, hard-coded into its learning process.
So it can't break the rules.
It cannot output a solution that violates the laws of physics.
So it's an AI that inherently understands how fluid and plasma behave in the real world.
Precisely. The SAPNN is responsible for real-time adaptive tuning of the weapon. Because the quantum lattice detector has already mapped the exact humidity, temperature, and wind conditions between the weapon and the predicted intercept point, the SAPNN knows exactly what atmospheric turbulence the plasma ring is about to face.
It knows if there's a rain cloud 2 miles out.
Exactly. So it dynamically tunes the microwave toroidal pulses, those 1 to 10 gigahertz fields we discussed earlier that shape the plasma as the ring is being formed in the chamber. It essentially dials a yield for each individual shot.
It customizes the plasma vortex for the specific weather it's about to fly through.
If the QLD detects a pocket of high humidity, the SAPNN shifts the microwave frequencies of the plasma to specific windows within the electromagnetic spectrum that have a lower rate of water absorption.
Fascinating.
If there is a strong crosswind, it adjusts the internal spin rate and the expansion velocity of the toroid to optimize its structural integrity.
It leverages the self-healing properties of a vortex.
Yes. A toroidal vortex naturally conserves momentum. If a force, like a crosswind, pushes on one side of the ring, the internal spin dynamics redistribute that energy across the structure to maintain the overall circular shape.
Amazing.
By perfectly tuning the launch parameters to match the environmental resistance, the AI ensures the plasma doesn't bloom.
Blooming meaning it loses focus and just expands into a useless cloud of hot gas.
Exactly. It prevents blooming, and it prevents backscatter, where the energy reflects off a dense pocket of air back toward friendly forces.
But wait, Even with an AI perfectly tuning the microwave frequency for the humidity, we are still talking about a ring of glowing plasma reaching stellar temperatures, physically flying at Mach 20.
That's right.
The sheer friction of pushing through the atmosphere at 20 times the speed of sound should rip any fluid structure to shreds instantly. How do we keep the toroid intact mechanically?
This brings us to the final piece of the emitter architecture, and one of the most extreme technologies in the document, the monolithic Hellback array.
I've been waiting to ask about this. The specifications state, these magnetic arrays generate fields between 10 and 100 Tesla.
Yes, which is immense.
For context, for those listening, a standard hospital MRI machine, the giant magnetic tube that requires you to remove all metal from your body because it can rip a steel chair across a room, operates at roughly 1.5 to 3 Tesla.
Right.
A 100 Tesla field is apocalyptic. How does a weapon generate a 100 Tesla field without ripping its own chassis apart, and what does that kind of magnetism do to the plasma?
Generating a 100 Tesla field requires extreme engineering. A Hellback array is a specific, specialized arrangement of permanent magnets.
Okay.
By rotating the orientation of the magnetic poles in a specific sequence, the array augments and dramatically strengthens the magnetic field on one side of the structure, while canceling the magnetic field to near zero on the other side.
Oh, I see. So it pushes all the magnetic force inward and nothing outward.
Exactly. The documents specify a monolithic Hellback array. This means the magnetic structure is manufactured as a single, continuous, defect-free unit without joints, seams, or mechanical fasteners that could fail under stress.
And where is it located?
This monolithic array is embedded deeply within that super-strong, heat-absorbing MXene-graphene aerogel core.
Ah, so the aerogel acts as the structural reinforcement holding this apocalyptic magnet together.
Because the magnetic force is directed entirely inward into the confinement chamber, and the field on the outside is effectively zero, the weapon doesn't magnetize its surroundings or rip itself apart from magnetic repulsion.
That solves the chassis problem. And what happens when you drop a 1,000,000-degree plasma kernel into the center of a 100 Tesla magnetic field?
It creates an inescapable magnetic bottle. As the femtosecond laser sparks the plasma, the Hellback array instantly compresses it. It squeezes the charged plasma kernel with unimaginable magnetic pressure.
Wow!
This inward pressure dramatically increases the plasma's density and temperature.
It physically crushes the smoke ring.
Most importantly, this intense magnetic compression suppresses internal fluid instabilities. In high-energy plasma physics, you have to deal with Rayleigh-Taylor instabilities and kink modes.
What are those?
They are phenomena where the plasma naturally wants to wriggle, break its symmetry, and dissipate its energy. The 100 Tesla field locks the plasma toroid into an ultra-rigid, magnetically reinforced structure.
It turns a delicate fluid smoke ring into a magnetically forged glowing buzzsaw.
That's a vivid way to put it, but accurate. This magnetic rigidity allows the toroid to maintain its perfect shape, its extreme heat, and its megajoule payload over kilometers of atmospheric travel at Mach 20, completely defying the friction that would normally destroy it.
That is absolutely terrifying.
It is formidable.
We have now perfectly established how to fire a single, flawless, world-ending smoke ring that can hit an invisible target miles away. But the iron vortex isn't designed for single-shot duels, right?
No, not at all.
It is designed to stop saturation attacks. It is designed to stop swarms.
Right. When you look at the strategic doctrine outlined in these documents, the reality of modern warfare is that a single interceptor is easily overwhelmed.
Right. If you have one bullet and 100 targets, you lose.
If an adversary launches a swarm of 1,000 cheap drones or a volley of multiple hypersonic glide vehicles simultaneously, a system that only fires once every few minutes is useless. The defense must transition from precision point interception to total area denial.
Creating a wall in the sky.
Yes. By combining all the interconnected subsystems we have unpacked, the 1 megawatt nuclear power pump providing limitless energy, the 30 gigajoule supercapacitor buffer managing the massive power spikes, the MXene-graphene aerogel immediately shedding the thermal waste, the QLD lattice mapping the invisible threats, and the SAPN adaptively tuning the magnetic buzzsaws. The iron vortex platform transitions from individual calculated precision shots to firing up to 60 bursts per minute continuously indefinitely.
1 megajoule to 10 megajoule bursts, firing every single second, nonstop.
Because the nuclear source acts as a continuous current pump, filling the massive capacitor bank exactly as fast as it empties. The weapon can sustain this maximum rate of fire for 10 to 100 minutes at a time.
That is an unbelievable amount of energy being projected.
It creates what the engineering roadmaps term a vortex storm.
A vortex storm.
This is a continuous, unjammable environment of plasma-acoustic disruption spanning the airspace above a defended asset. It projects a physical and electromagnetic barrier into the sky that nothing can pass through.
So what actually happens when a hypersonic missile or a swarm of drones flies into this vortex storm? Because it's not just a physical wall, right?
No, it's not. The iron vortex utilizes a multi-layered kill mechanism. It does not rely on just one single method of destruction. It hits the incoming target with 3 simultaneous catastrophic effects.
The first of those being the soft kill. How does a plasma ring perform a soft kill?
The soft kill relies on plasma-induced EMP-like effects and acoustic resonance. As these megajoule rings fly through the air, highly compressed by the Hall-back arrays, their intense moving magnetic fields generate a massive, broadband electromagnetic pulse.
An EMP.
Yes. If an unshielded drone or a missile relying on GPS and internal gyroscopes enters the periphery of this storm, this broadband EM radiation induces massive, uncontrolled electrical currents inside the target circuitry.
So it just overloads them.
Through a process similar to Compton scattering, the radiation violently strips electrons in the wiring, causing power surges that immediately fry navigational sensors, blind optical seekers, and cause catastrophic logic failures in the flight computers.
A digital lobotomy.
Exactly.
Yeah.
Simultaneously, the acoustic shockwave generated by the rapidly expanding plasma in the atmosphere causes intense physical vibrations.
It's loud.
Incredibly loud. This acoustic resonance shakes delicate internal components, potentially shattering crystal oscillators or microelectromechanical systems inside the missile.
So even if the missile doesn't get directly hit by the plasma ring itself, just flying near the storm blinds it, breaks its inner ear, and it completely loses all guidance.
It becomes a dumb rock falling from the sky.
But what if it's a hardened, shielded nuclear missile designed to survive EMPs?
That brings us to the second layer, the hard kill. The hard kill is physical plasma ablation. If the target makes physical contact with the plasma toroid, it is subjected to the core temperature of up to 1 million Kelvin.
The stellar core temperatures.
Right. At 10 megajoules of energy, this extreme heat is fundamentally incompatible with solid matter. It instantly melts and vaporizes aerospace-grade materials, whether it's a titanium hull or a carbon composite heat shield.
It doesn't matter how thick the armor is.
The intense, highly localized thermal shock causes catastrophic structural melting. It burns right through the outer hull, completely compromising the aerodynamic integrity of the airframe.
At Mach 10, if your aerodynamic integrity is compromised even slightly, the air pressure will rip the missile apart.
Yes, it turns a sleek aerodynamic dart into a melted asymmetrical lump of slag, which immediately tears itself to pieces from atmospheric drag.
Brutal.
And finally, there's the third layer, the kinetic knockdown.
Wait, I thought this was a non-kinetic weapon.
The projectile itself is non-kinetic. It has virtually no mass. But the effect it has on the atmosphere is kinetic. The kinetic knockdown relies on focused impulse.
How does that work?
When the highly compressed, magnetically confined plasma ring impacts a physical target, the magnetic bottle is broken. The plasma rapidly expands back into a gas, transferring all of its forward momentum in a violent, supersonic shock wave.
A massive explosion of air pressure.
It delivers an immense physical knockdown force. Even if a target somehow survived the EMP and possessed some theoretical armor that resisted the thermal melting, the sheer kinetic slap of this shockwave is enough to violently alter the trajectory of a high-velocity projectile.
Wow.
It physically knocks the threat completely off its flight path, tumbling it out of control and ensuring it misses the defended area entirely.
Okay, this is incredible, but I have one massive operational concern with this entire concept.
What is that?
You are creating a storm of broadband EMPs, million-degree plasma, and supersonic shock waves directly above your own military base or your own aircraft carrier strike group.
That is true.
How does projecting a vortex storm not instantly blind our own radar, fry our own communications, and destroy our own equipment? Aren't we just nuking our own electronics to save ourselves from the missile?
That is a very valid concern, and it is a problem the engineers addressed at the foundational material level. It all ties back to the material science we discussed at the beginning. Remember the MXene-graphene composite used for the aerogel cooling?
The 2D material that drinks the heat and routes it away.
Yes. Beyond its exceptional thermal properties, MXene-graphene composites double as arguably the best EMI shielding, electromagnetic interference shielding, ever theorized.
Oh, really?
Because these materials are highly conductive in specific controlled tensor directions, they form a near-perfect Faraday cage.
A Faraday cage being a mesh that blocks electromagnetic fields by distributing the charge around the exterior.
Exactly. The blueprints state that this MXene-graphene shielding is not just integrated into the weapon's internal confinement chamber. It is designed to be applied to the outer chassis of the weapon, the local command centers, the radar installations, and all friendly technology operating in the vicinity of the iron vortex.
It's an armor plating for electronics.
The material absorbs and safely routes the chaotic broadband EMP energy of the vortex storm around the sensitive friendly electronics, grounding it safely.
Wow.
It protects our infrastructure while leaving the unshielded incoming enemy threats fully exposed to the digital lobotomy of the disruption.
So our technology is wearing heavily polarized sunglasses, and the enemy is staring directly into the sun.
Exactly. The system protects itself and our troops through the exact same material science that allows it to manage its own heat in the first place.
It is a brilliantly elegant, closed-loop engineering solution.
It really is.
It is absolutely wild. Let's summarize the incredible journey of this deep dive. We started with a theoretical physics concept, a plasma-acoustic toroid, essentially an electromagnetic smoke ring sparked by a femtosecond laser causing avalanche breakdown in the air.
Right.
We saw how the catastrophic heat of generating a megajoule burst is managed by the miraculous tensor thermal conductivity of an MXene-graphene aerogel core acting as a phase change material.
We then explored the scaling up of the platform, transitioning from a tactical battery to the strategic iron vortex by utilizing a 1 megawatt nuclear power SMR to continuously trickle charge a massive 30 gigajoule supercapacitor buffer.
Which completely bypassed the limits of chemical batteries, allowing for instantaneous gigawatt power releases without crashing the nuclear reactor.
Exactly.
Then we looked at the targeting, how the quantum lattice detector abandons traditional radar entirely, mapping the atmosphere at an atomic level to reveal the displaced air, the quantum wake of invisible stealth targets.
And how the SAP and artificial intelligence utilizes that atmospheric data to dynamically tune the frequency of the plasma rings in real time, dialing a yield that allows them to survive rain and crosswinds.
While being physically compressed into ultra-rigid, highly stable structures by 100 Tesla monolithic Halbach arrays, completely suppressing natural fluid instabilities.
Right.
And finally, how all of these impossible technologies converge to allow the iron vortex to fire 60 times a minute, creating a sustained, impenetrable vortex storm.
A wall in the sky.
A wall in the sky that neutralizes saturation, swarms through EMP frying, million-degree plasma melting, and kinetic knockdown, all while perfectly shielding friendly forces with those same 2D nanomaterials.
It emphasizes that the future of defense isn't about forging thicker steel armor or building faster kinetic missiles. It is about deeply understanding and manipulating the fundamental forces of physics, heat, electromagnetism, and fluid dynamics at a molecular and quantum scale.
I hope this deep dive into these blueprints has been as mind-expanding for you as it has been for me. While this sounds like extreme military science fiction, it is a masterclass in how multiple cutting-edge disciplines, nanomaterials, quantum sensing, AI neural networks, and advanced nuclear engineering are colliding right now to solve impossible physics problems.
But before we sign off, there's one major implication here that extends far beyond missile defense.
Exactly. I want to leave you with a final provocative thought to mull over based on everything we've learned today. We talked about the quantum lattice detector perfectly mapping the molecular structure of the atmosphere.
Yes.
It finds the minute gravitational and electromagnetic disturbances caused by a missile simply taking up space, simply displacing the air around it. If that quantum sensing technology exists, does this mean the entire concept of a stealth aircraft is functionally extinct?
It's a profound question. If you cannot hide your physical displacement of air, if your very existence in the atmosphere leaves a highly visible quantum wake that AI can track instantly, then radar absorbent paint and clever geometric angles no longer matter. You cannot be stealthy if you take up physical space.
Has the multi-trillion-dollar arms race of aerodynamic stealth just permanently ended? It is a fascinating question for the future of aerospace engineering and warfare. Thank you so much for joining us on this custom deep dive. Keep questioning the consensus, keep looking past the concrete walls, and keep diving deep into the world of tomorrow. We'll see you next time.